by friction in the trajectory toward crafting more energy-efficient technological marvels. 5. The innovations of friction stir welding. Innovation knows no bounds, and within the realm of welding, an ingenious technique harnesses friction's prowess to join materials sans the need for melting. We delve into the scientific intricacies governing friction stir welding, casting a discerning eye on its versatile applications spanning across aerospace, shipbuilding, and myriad other industrial domains. The discernment of friction's imprint upon the orchestration of heat and energy transference stands as an indispensable pursuit for both engineers and scientists, forging ahead on the quest to optimize systems for the dual imperatives of energy efficiency and astute thermal management. Friction, as an alchemical force, begets not only heat but also orchestrates the melodious cadence of sound. With rapt attention, we navigate the acoustic symphony orchestrated by friction, a subtle maestro that conducts its influence across our universe. 1. The overture of sound genesis. When materials in motion lock in a frictional embrace, a peculiar alchemy transpires, birthing sound waves as their harmonious offspring. We embark on a voyage to unmask the profound mechanics underpinning sound generation through the agency of friction, shedding light on the multifarious factors that choreograph the intensity and frequency of the resultant harmonies. 2. The artistry of sound abatement. The art of sound abatement, a harmonious blend of engineering ingenuity and friction's soft caress, finds application in diverse arenas. Here, we venture into the realm of sound-absorbing materials and techniques, artful contrivances that harness the gentle force of friction to quell the cacophony in domains as varied as automotive engineering and architectural design. 3. The echelons of musical instruments. In the world of music, friction is the silent virtuoso behind the ethereal melodies produced by instruments such as violins and pianos. Our discourse unveils the pivotal role of friction in these lyrical contrivances, casting light on its contribution to the harmonious tapestry of musical artistry. 4. The tremors of seismic friction. In the geological lexicon, friction begets seismic upheavals, where tectonic plates engage in a tumultuous dance. Our journey takes us deep into the terrain of seismic friction, laying bare its intricate role in the genesis of earthquakes and the majestic shifts of tectonic plates. 5. The orchestration of friction-driven acoustics. In the domain of innovative technology, the subtle wizardry of friction is harnessed to craft soundscapes, exemplified by friction drums and the enigmatic singing rocks. We embark on a mystical expedition into the science underpinning these unique acoustical marvels, where friction assumes the role of a silent maestro. The study of the sonorous echoes birthed by the union of friction is a riveting exploration, bearing both intellectual fascination and pragmatic relevance. It finds applications in realms as diverse as noise abatement, the crafting of musical instruments, and the comprehension of nature's geological tapestry. In the realm of physical forces, friction exerts its influence across a spectrum spanning from the grandiose to the minuscule. In this discourse, we shall embark upon a captivating odyssey through the enigmatic domain of friction, focusing our lens upon the minute and infinitesimal dimensions. 1. Subatomic friction. In the diminutive expanse of the subatomic, the interplay between atoms and molecules unfolds through the orchestration of van der Waals forces and electrostatic interactions, culminating in what we term subatomic friction. Our journey will involve a meticulous examination of the repercussions of this phenomenon on the behavior of materials at the atomic level. 2. Nanoscale tribology. The field of nanotribology, which probes the intricacies of friction at the nanoscale, assumes paramount significance in the quest for innovations in nanotechnology. We shall embark upon an exploration of the endeavors undertaken by scientists and engineers to harness nanoscale friction's potential in the design of novel materials, sensors, and devices. 3. MEMS and NEMS apparatus. The domain of microelectromechanical systems MEMS and nanoelectromechanical systems NEMS pivots upon the nuanced control of friction at minuscule proportions. Our voyage will lead us to an understanding of their applications in sectors as diverse as medical devices, sensors, and telecommunications. 4. Nanostratum coverings. Coatings crafted at the nanoscale wield the power to abate friction and mitigate wear in a range of applications, including the domains of automotive propulsion systems and biomedical implants. Our foray shall delve into the intricate science underpinning these nanoscale coatings and their profound influence on the diminution of friction. 5. Tribological impacts on data repositories. The subtle forces of friction, when manifesting at the nanoscale, exert their sway over data storage devices such as hard disk drives and flash memory. We shall elucidate the strategies engineers employ to govern friction, thereby enhancing the performance and durability of these data storage mediums. A profound comprehension of friction's subtleties, whether within the microcosm or the nanoscopic realm, serves as an indispensable catalyst for progress in diverse sectors, ranging from electronics to healthcare. It emerges as a linchpin in the panorama of forthcoming technological advancements. Amid the global focus on sustainability and the quest to curtail energy consumption, comprehending and mitigating friction becomes paramount. In this discourse, we shall delve into the substantiality of diminishing friction and its role in paving the way for a sustainable future. 1. Energy efficacy. Friction within industrial and transit systems precipitates energy dissipation. We shall elaborate on the manner in which ameliorating friction through advanced materials and lubricants can bolster energy efficiency and ameliorate the mitigation of carbon emissions. 2. Eco-conscious lubricants. Conventional lubricants are fraught with deleterious environmental consequences. We shall scrutinize the development of environmentally responsible lubricants that not only effectuate effective friction abatement but also uphold eco-friendliness. 3. Tribology in sustainable energy. The advancement of renewable energy technologies, such as wind turbines and solar panels, hinges upon the minimization of friction. We shall delve into the pivotal role of tribology in augmenting the performance and longevity of these systems. 4. Sustainable mobility. Electric vehicles and public transit systems are committed to mitigating their environmental footprint. We shall expound upon how technologies aimed at diminishing friction wield a profound influence in the realm of sustainable transportation solutions. 5. Ecological manufacturing. Practices advocating sustainable manufacturing pivot around the reduction of waste and energy consumption. We shall scrutinize how strategies focused on the abatement of friction in machining, molding, and analogous processes contribute to eco-conscious manufacturing. The imperative of minimizing friction extends not solely to the enhancement of technology but also to the construction of a more sustainable and environmentally accountable future. Friction assumes a defining role within the arena of sports, exerting an influence over performance, safety, and even the framework of the games themselves. In this exploration, we shall unveil the multifaceted impacts of friction across a spectrum of sports and athletic pursuits. 1. Tennis and racket sports. Friction serves as a pivotal determinant in the interaction between the ball and players on the tennis court. We shall expatiate on how distinct court surfaces, racket string compositions, and ball varieties reverberate within the game. 2. Running and traction. Runners are reliant upon the friction between their footwear and the ground to ensure stability and velocity. We shall plunge into the scientific intricacies of running shoe design and the manner in which athletes optimize their footwear for diverse terrains. 3. Motorsport racing. In the realm of motorsports, friction wields authority over a vehicle's adhesion to the racetrack. We shall investigate how engineers and drivers adroitly manage friction to refine racing performance and safety. 4. Winter athletic pursuits. Friction, or the scarcity thereof, holds sway over winter sports such as skiing and snowboarding. We shall dissect the role of wax applications, edge adjustments, and ski material selection in optimizing friction across varying snow conditions. 5. Golf and greenskeeping. In the realm of golf, the smoothness of greens and the interaction of the ball with the grass are markedly subject to the influence of friction. We shall explore how course maintenance and equipment design leave an indelible mark on the sport. Understanding the multifarious facets of friction within the world of sports not only captivates enthusiasts but also emerges as an imperative pursuit for athletes and sports engineers keen on securing a competitive edge. In the realm of medicine, friction stands as a foundational consideration, exerting its influence on various facets, ranging from the blueprint of medical apparatus to the functioning of biological systems and the security of surgical procedures. Allow us to embark on an exploration of the multifaceted role that friction plays in the realm of medicine. 1. Prosthetics and orthopedics. The world of prosthetic limbs and orthopedic implants is heavily intertwined with the pivotal role of friction. We shall delve into how engineers meticulously optimize this force to enhance both mobility and the comfort of patients. 2. Biomechanics. Within the human body, friction serves as a vital force governing the movement of joints, muscles, and tendons. Our journey will encompass the intricacies of biomechanical friction and its profound relevance in comprehending and addressing musculoskeletal disorders. 3. Traction and traction devices. Medical procedures employ traction to reset bones and alleviate pressure on the spinal cord. Our discourse will revolve around the principles governing traction and the methods used to manage friction in these devices. 4. Artificial joints. The success of joint replacement surgery hinges on the minimization of friction between the components of artificial joints. We shall plunge into the materials and lubrication methodologies employed to curtail wear and enhance the longevity of these prosthetics. 5. Surgical instruments and safety. In surgical scenarios, prudent friction management is imperative to ensure precision and safety. Our exploration will encompass the role played by friction in the development of surgical instruments and techniques, upholding the sanctity of medical procedures. Comprehending the pivotal role of friction within the medical realm is paramount for the progression of patient care, the prolongation of the lifespan of medical devices, and the enrichment of the quality of life for individuals contending with musculoskeletal conditions. The study of friction forms an ever-evolving field, promising a future brimming with exciting prospects. Join us in unraveling the emerging technologies and applications that are sculpting the destiny of this fundamental force. 1. Nanomaterials and nanotechnology. Breakthroughs in nanotechnology bestow upon us the unparalleled ability to meticulously manipulate materials at atomic and molecular scales. Our conversation will shed light on how nanomaterials are instigating a paradigm shift in our capacity to regulate friction and forge inventive products and devices. 2. Cognizant lubricants. Lubricants have undergone a transformation, assimilating sensors and data-driven technologies into their repertoire. We shall embark on an exploration of how these innovations elevate the surveillance and administration of friction across various systems. 3. Friction-reducing coatings. The arena of advanced coatings and surface treatments presents us with the opportunity to curtail friction in pivotal applications, extending from aerospace components to medical implants. 4. Biologically inspired design. Nature, in its wisdom, has honed the art of friction reduction in various life forms. Biomimicry serves as a fount of inspiration for engineers seeking novel solutions in fields like transportation, robotics, and medical devices. 5. Tribology in space. As humanity boldly ventures into the cosmos, the discipline of tribology, which delves into friction, wear, and lubrication, assumes a position of paramount importance in spacecraft and extraterrestrial environments. Let us embark on a journey to fathom the role of friction in the domain of space exploration and colonization. The forthcoming realm of friction opens up a realm of boundless potential, spanning from enhanced energy systems to groundbreaking medical innovations. By perpetually embracing the vanguard of friction-focused research and technology, we can persistently push the boundaries of what is achievable within the domains of science and engineering. Friction, primarily entrenched in the domains of science and engineering, inevitably begets profound ethical contemplations as its multifaceted influence on various facets of our existence becomes progressively conspicuous. 1. Environmental moral dilemmas. In our pursuit of sustainable methodologies, the imperative ethical duty lies in the minimization of friction to curtail energy consumption. We shall elucidate the ethical tenets that serve as guiding principles in the embrace of technologies and conduct that are cognizant of friction's ramifications. 2. Ethical quandaries in healthcare. The intricate matter of employing friction reduction materials and technologies in healthcare engenders ethical intricacies. Striking a harmonious balance between patient comfort and well-being and the indispensable effectiveness of medical apparatuses bestows ethical dilemmas upon us. We shall embark on a profound exploration of these quandaries. 3. Ethical oversight and safety. In industries such as automotive and aviation, the abatement of friction is of paramount importance for safety. We shall delve into the ethical obligations binding manufacturers and regulators in their pledge to ensure that friction-related technologies conform to the loftiest safety standards. 4. Data confidentiality and security. In our embrace of intelligent and interconnected technologies reliant on minimized friction in data processing, ethical apprehensions concerning data confidentiality and security have ascended to the forefront. We shall scrutinize the ethical dimensions underpinning the handling and safeguarding of data. 5. Equitable dispensation of friction reduction technologies. The virtues of technologies aimed at friction reduction should be equally accessible to all. We shall contemplate the ethical ramifications entailed in guaranteeing impartial access to innovations that amplify efficiency and abate wastage. Delving into the ethical dimensions of friction augments our discernment of the far-reaching impact of this fundamental force and accentuates the imperative nature of judicious decision-making in its deployment. Our exploration of friction, spanning from its rudimentary aspects to its ethical entanglements, has unfurled as an extraordinary odyssey. It has unveiled how this seemingly unobtrusive force molds our world in manners that may not invariably be discernible. As we draw this literary work to a conclusion, it is of paramount import to recognize that the study of friction is a field removed from its culmination. It constitutes a realm in ceaseless evolution, propelled by strides in materials science, nanotechnology, and our comprehension of intricate systems. Friction stands as an enigma with constituents that transgress the precincts of scientific disciplines and infiltrate our quotidian existence, our technological landscapes, and our aspirations for an ecologically sound and innovative future. We trust that the science of friction and motion has conferred upon you a more profound reverence for the role played by friction in our universe and the inexhaustible potential it harbors. We entreat you to remain inquisitive and to persist in your expedition through the universe of friction, for it is an expedition devoid of terminus. Thus, whether you are an ardent devotee of physics or simply harbor a curiosity regarding the curious phenomenon of your coffee cup's tenacity to remain stationary on your table, comprehending the far-reaching effects of friction on the kinetics of motion is of utmost importance. We express our gratitude for your presence today on Cyvid, as we navigate the labyrinthine domain of friction. Should you derive satisfaction from this presentation, we kindly beseech you to bestow your favor upon the like button and subscribe for further captivating odysseys through the vast realms of scientific exploration and the captivating realm of physics. Until we rendezvous again, retain your curiosity intact.